Thank you for joining us here. I know it's lunchtime and I really appreciate you all coming. My name is Ankur Kotwal and I'm a developer advocate at Google Cloud. So I've been at Google in the developer relations team for about 7 years. And for much of that time, I've actually been working with game developers. So developer relations at Google is, we're like a conduit between our internal engineering teams and third-party developers. We make sure we're listening to you to take that back to our product teams and help them sort of prioritize and define roadmap of the products that you would like us to bring to market or the types of problems you'd like to solve. And similarly, when we are ready to bring that to you, developer relations is there to talk to you about it. We write blogs, we do sample code, do our docs and videos and so on. So I've been a passionate gamer since I was very young, and I've been working with game developers for quite a few years now. So this is a space that's really, really interesting to me. So today, I want to talk to you about connected games. You may have heard that Google and Unity announced an alliance, a strategic alliance, reasonably recently. How many of you have heard about that? There's a couple of hands going up. Good. And it's really about us trying to solve problems together. And that's what today's talk is about. We're going to be focused on the connected game space. And there is a talk later on today at 3 o'clock for a different space as well. And then we'll talk a little bit about that. We'll share about how we're bringing the power of Google Cloud into this alliance. And I'll give you a glimpse of the Unity roadmap, Unity and Google combined roadmap as well. OK, so of course we have to. There we go. So you may be saying, well, what are connected games? It's a fairly broad term. What does that really mean? It's effectively a new initiative for Unity in collaboration with Google Cloud. We want to have a holistic view to democratize building connectedness across the spectrum. So that's from dynamic single-player games like Pokemon Go to MMO persistent worlds like Crowfall as well. And we think that all games benefit from connectivity between players, between content, and of course, you, the developer, as well. Now, what we found is that connected games are the most played, the most watched, and the most financially successful games out there. So no matter how you slice it, players are enjoying games that branch out beyond a static game client and into worlds that introduce them to new people and new challenges every day. And you might be saying, well, why is it? Why is this the case? Well, from what's been observed, increased connectedness leads to greater engagement, which means that people are playing your games for longer, which in turn presents more opportunities to retain and monetize your games. Now, that doesn't mean that all games should be multiplayer specifically, right? There's a broad spectrum of great games, and many players really enjoy their solo experiences. Instead, Unity have been thinking about the levels of connectivity, and each level is valuable. There isn't one that's better or worse than the other. But as you move through these levels, as you go from level 1 to level 4, the tech complexity, community, and game design challenges grow. This is a cumulative set of levels. And to focus our efforts, we've broken the levels down into 4 segments that have similar problems and compute solutions required. So as a quick overview, we're going to dive into these in upcoming slides, but as a quick overview, we have level 1 for connected single-player games like Angry Birds, where the gameplay is single-player and the connectedness typically comes from features that are found outside of the core gameplay loop. Things like daily challenges or leaderboards. Level 2 is asynchronous multiplayer, games like Hearthstone, where players interact directly, but in a latency-tolerant way. They pass game states and control back and forth. This level is where real connections between people typically become more important. Level 3 is with real-time multiplayer instance games like Titanfall 2, where they depend on real-time connections between players. And the most critical component ends up being these complex networking solutions. Level 4 is persistent shared world games, MMOs like Crowfall, which keep players connected all the time in worlds that are never offline. Complex server structures are required to manage these games, and they're a necessary component, not to mention other expectations around economies and communities and more. So, let's dive into level 1, dynamic single player. One of the biggest challenges of these types of games is retention, because the vast majority of players that download games never play the game for more than a single session. Game developers work really hard to even get these players to peek into the door, but what tools could you use to pull them in even further? Let's look at a couple of those. One common approach is to offer incentives, sometimes even several forms within the same game. Things like leveling and achievements and item inventory. These can be quite effective and are often the first step in the door, but novelty is key. If players run out of incentives, they stop playing. So where do you store new rewards and assets? How do you make sure that there's enough forms of incentive to unlock? How do you build your games with hooks that enable the dynamic addition of new rewards without requiring patches and game updates? Beyond incentives, another powerful motivator is competition. Even in single-player games, competition can be powerful as long as there's a score or timer or challenge, like in Pokemon Go gyms. Do you do things like leaderboard only, or do you pull it directly into the solo gameplay? Again, like gyms. What about player IDs and profiles? How are they represented in your game? Where are you going to make those and where are you going to store those? Another motivation is cooperation. You want to allow players to independently, at the same time, work towards the same goal. Or find a way for them to combine their power or skills or score to attempt to defeat an extra hard challenge. Now, each of these have their own considerations. With a shared goal, how do you communicate that shared progress in a reasonably fast way? Do you do it with like a shared health bar? What's the technology that you use behind this? Do you use like a real-time database to synchronize that information between all the clients? So that's level 1. Let's look at level 2, which is asynchronous multiplayer. And here, you face many of the same challenges as level 1, but with some new additions. Now you're playing directly with another person. The interactions between them becomes more complicated. And we also have to consider how we share the game state. And how do we do it in a latency-tolerant way? So, when we play multiplayer games, like, again, we're seeing Hearthstone here, you want to be able to find people to play with, because interactions in this type of game make or ruin an experience. So, you need to make a decision. Do you allow people to only play with friends? Now, the nice thing about playing with friends is that friends are typically safe. We like to be able to direct chat with them, and we can have a certain expectation of the quality of the experience we're going to have. But it's hard to always find friends to play with. Right? They're not always on at the same time as you. They're not always in the same location as you, and so on. Then you could open it up to strangers, but strangers are scary. And in this case, Hearthstone sort of went with this emote system, which allowed players to communicate with each other, but with a very simplified set of language. So you can sort of convey that emotion that you want to the other party, but in a non-toxic way, because you're restricted to that vocabulary. But then we also end up with this other challenge of like, well, if you're now being paired up with strangers, how do you match one player with another player? That's what we call matchmaking. And there's a dedicated talk, I alluded to this earlier, we'll talk a little bit about matchmaking, but there's a whole other talk on matchmaking later today. And then what about your core asynchronous multiplayer technology? Even with latency tolerance, you have to be able to pass game state back and forth. Now, you have a couple of ways to do this. You could do it where you finish an entire turn, or you can pass in separate steps along the way. And that way, if you're only doing steps, then it looks like it's real time, even though it may not exactly be real time. And Hearthstone does this really well. It doesn't wait for your whole turn of cards to be played before it sends that information to the player. As player one is attacking or casting a spell, even hovering over cards, that state is being passed to the other player. And even if it arrives half a second later, it's not a big deal. Because to the player who's watching these animations come through, it feels real-time enough. And in most common level 2 game structures, it's actually the player's game client that's responsible for creating its own data. But of course, if clients are creating their data, it's going to now become tricky to detect cheating. And if it's hard to detect, how do you prevent it? So in games that are competitive, cheating and hacking becomes a really major challenge. Now you could detect it by doing things like pulling analytics and running logic on it to detect anomalies, and then once you've found something, you could then maybe ban that player's account. But that's kind of after the fact. If you want to prevent that sort of thing from happening, prevent bad experiences sort of taking place, what you could do is run authoritative game logic in the cloud. So for example, if your game is rolling dice, you could ask the game client to roll that dice on the server and return the result of that dice roll so that you can ensure that there's equal distribution for all those numbers, the possible combinations of that dice. All right, let's move on to level 3, which is real-time multiplayer instance games. And this is where the first out of these levels is the first level where low latency becomes a really critical factor. Because it needs to feel like you and the other people in the match are truly moving and acting in the same space at the same time. Unfortunately, good real-time technology is also expensive to build and manage. And especially in competitive multiplayer games, cheating and toxicity in the community can be very hard to manage. So when you require some extremely low latency, especially in very fast competitive multiplayer, every millisecond counts, and the pressure is on in every sense. So when you do real-time connections between players, there's 2 typical paths. You can kind of do that model up the top, the peer-to-peer direct connect model. And that's what's been relied on at Unity so far because it's relatively inexpensive. You just have the clients kind of passing around data and synchronizing it amongst themselves. However, most games struggle to make it work. And especially as you start to scale that, you can see how reasonably simple it looks with 3 players, but as you start to scale it out, it becomes more and more complicated. The other way to do it is with a dedicated game server, where you have a server, like server authority. You have consistent connections between the clients and the server. You can now scale to all population sizes, assuming your infrastructure can do so as well. But you get security, you can do things like rapidly put in server-side fixes without requiring client patches and updates. But these are just some of the benefits that you get from this dedicated game server model. Now we love communities. Communities are what makes a game feel approachable. It's what makes players feel comfortable and want to spend more time in your game. But it turns out that passionate gamers aren't always tactful. Actually, you could generalize that about the internet as a whole, but speaking about gamers in particular, what we need to do as developers is provide tools to facilitate that kind of management. So with in-game chat, offering options like being able to mute players or perhaps doing the Hearthstone type approach of like simplifying the vocab to have emotes is one way that you can manage it. If you have clans and guilds in your games, you need to find ways for them to help them manage those themselves because typically clans and guilds are good at self-management, but it does depend on you providing the tools to them. Now forums and sort of offline chat can be really good tools, things like Discord and so on, but it's always hard to get enough community game managers to actually help sort of steer that community. And then with player management, it's inevitable that at some point you're going to need to provide a way for players to be able to report other players' bad behavior. Now, once you provide that way for them to do that, you have to do the other side of it, is have the appropriate tools for you to verify those reports and then be able to act on those as well. Level 4 games are persistent world games where not only do players expect that real-time interaction, but they also expect that worlds are always online and that they persist for years. These games come with all of the previous challenges discussed, and often to a much greater extent. It's a huge space, so for the sake of this talk, we're just going to touch on one new topic of persistent world technology. So to keep a persistent world running, it's generally impossible to keep thousands or millions of players on a single server at a time. Passing that many players' data back and forth makes most games unplayably slow. Instead, you have to devise a system of splitting players across servers and have meta servers managing the spin up and spin down of different servers of each major zone in your game. So how do you make sure that then friends and clan members are able to see each other and play in the same game? What happens when you need to run maintenance to a server box? How do you recover if one of your servers goes down? And how do you make sure that no game progress is lost if something like that happens? The resulting server structure ends up pretty challenging. So the diagram that I've shown here is actually the simple version that's described on MMORPG.com. And this is why it's still so hard to create persistent world multiplayer games, and why there really haven't been ideal solutions to improve it yet. So here's our abbreviated summary of the different levels and some of the challenges that come with each of those. And just to reiterate, each of those levels is cumulative. So it has the problems that are in the level above it too. So the ultimate goal at Unity is to democratize connected games across the board, to reach a point of ease of use and cost that many more developers can reach. That includes improving ease of use and reducing costs across the board. And it's been said that you should always build for success from the very beginning. So let's assume that your game takes off wildly tomorrow. Suddenly it's played by millions of players around the globe. Will your connected game continue to run? Or will you lose many of those new users due to connected services failing? We know it's our responsibility to provide top quality services that you can trust to power your games at any scale, including the flexibility required for unique games, fast response times, and with reliability you can trust with your beautiful game. Which is where Unity and Google have started working together, because a lot of the problems that we've just described are things that are challenges that Google has seen in the past and has been building up with Google Cloud to bring to market. Google is also a leader in open source. We have over 2,000 projects on opensource.google.com, and we are a champion of the open cloud. We don't believe in lock-in. So we can scale up game servers at 1/5 of the time of any other public cloud, and our unique cloud innovations have enabled new game designs. I'm going to give you an example in a minute. The more connected a game gets, the more it needs cloud infrastructure. And Google Cloud is working with Unity to give you direct access to that powerful infrastructure as a transparent part of your Unity developer experience. You'll be able to continue to use the same Unity development environment to leverage Google Cloud's unique and powerful infrastructure to make great games, and you don't need to spend time wondering if you're configuring the cloud correctly. We're going to do that work for you. You'll have access to innovative new game designs, expert infrastructure management, and industry-leading data and analytics tools. Through Unity, we'll expose these features to you transparently to accelerate innovation, improve launch quality, and optimize player engagement. So remember earlier I said innovative new game designs? You might be like, well, these sound like buzzwords. What's an example of that? There's a game that launched just a couple of months ago. It's a mobile game. And it has a unique architecture. It's doing things a little bit differently. So I have a short video from the developers that kind of describes what they did, as well as a demo of the game itself. So let's make sure the audio is good.
One of the biggest features that we have for this game actually is the global real-time player versus player on Cloud Network. So let me say that one more time. It's global, it's real time, and it is actually player versus player. We're not going to muck around with by providing pseudo experiences of player versus player where players fight other player datas. It's not going to be like that. We'll actually have the players be fighting one-on-one, anywhere, anytime. So, you know what, to give you a really good idea as to what it'll be like, we're actually going to have a live demonstration between 2 points. And point A being here, Moscone Center, where Keigo will be playing against another team member of ours that is currently in Japan, our Tokyo headquarters actually. So I just copy and pasted the Google map actually, but as you can see, there's 5,100 miles apart. Oh yeah, that's Ayaka, that's one of our team members. And so she's currently in Tokyo right now. The right screen is her mobile app screen. Left screen is Keigo's, and I would appreciate it if the audio was played in the background a little bit louder. Yes, thank you. Okay, so the game itself is one-on-one, but each player can bring up to 3 playable characters. The objective of the game is to defeat the opponent's 3 characters before the opponent. All right, and they're both ready. So, thanks to Google's cloud networking, we managed to create a really stable playing field where users don't really need to worry about internet connection, latency, and whatnot. All they need to worry about is the opponent that's going to be in front of them on the screen. All right, it seems like the game connected, and it's still black. Oh, there we go. Thank God. Check. So, the game started right now. Left screen is Keigo. He will probably show off some of the cool cutscenes that each character has, but it's heavily action-oriented, but in actuality, the controls are quite simple. We made sure that it's intuitive, and we made sure that everybody who wants an action game on Dragon Ball can play other players without having to worry about getting their butt handed to them. So, as you can see, Ayaka just activated her special skill. The 4 cards that can be seen on the bottom of the screen, those are universal cards that each player has. And whenever you tap them, the character will automatically do an action oriented to that specific card. And each character will have something different. For example, you tap the red card, you can do a melee attack. You tap the yellow card, you can do a long ranged, and the blue one is a special attack. And also, by tapping them consecutively, the character will automatically create combos. So, just like right now, actually. It's a special cutscene right now, and it looks really complex when you first see it, honestly. But, oh my God.
All right, clearly someone was very excited about winning at a demo. So I mentioned earlier that we're talking about sort of innovative new architecture. So they've basically built this real-time fighting game that is able to span the globe, and they're not actually instancing players around specific regions. What they're doing is using a product called Cloud Spanner, which is effectively a database. And I'm going to talk a little bit about that right now. So with Google Cloud and Unity working together, we've made these sorts of architectures much easier. So many developers kind of use MySQL for their database, but Cloud Spanner is what's becoming quickly the preferred choice for AAA studios. So Cloud Spanner, just to give you a quick overview, is a global relational database for all your game servers. So in this particular example, you can do something like write data once in Japan, and as soon as that write has completed, you can read it on the other side of the world, in the US, in Brazil, or wherever it may be. So what that means is that rather than having these complex sort of networking calls and waiting for those things, we're just able to rely on that scalable real-time database to solve this sort of problem for you. And what we're looking to do is bring Cloud Spanner to Unity developers with a simple-to-use interface. And we're going to talk more about that in the coming months. So there's more than just this to the Unity and Google Cloud relationship. Whilst we're really proud of our cloud infrastructure, it's really the people that make it special. So I want to show you another example, another quick video. It's about 1.5 minutes, where customer service is what really made the difference. This video is in Japanese, so there are some subtitles here, which I believe you should be able to see. Oh, no.
配信開始から4日間で4000万ダウンロード スーパーマリオランはこれまでにないスピードで世界中の方々にお届けすることができました。世界中の方々に向けて150カ国同時に配信を目指しておりまして、これが非常に困難なことは目に見えていました。リリースのわずか3ヶ月前ですけれども GCP を使う決断をしました。
最も大きな懸念は集中するトラフィックによってオペレーションコストが増加したり、オペレーションのミスによってシステムが落ちてしまったりすることですかね。 Google アップエンジンのオートスケールならば、ミリ秒単位でサーバー数を最適化できるので、この問題を解決できるんじゃないかと思っていました。またビッグクエリーを使えばアプリで発生した大量のアクティビティを簡単に蓄積することができ、今後のアプリに向けた分析を瞬時に行うことができます。
配信の3ヶ月前、 Google のエンジニアさんとお会いしまして、クレイジーだって言われました。本当に言ってんのみたいな状態だったんですけど、皆さん必死に応えてくれて、僕自身はやっぱりこのチームは最高のチームだなって思います。
So we've talked about our infrastructure, our scalability globally. We've talked a little bit about the customer service that we bring to bear. I want to talk about another area that's become increasingly an area of interest, and that's machine learning. Now, we know that Google Cloud has been a great place for machine learning, and across Google, we're pushing to democratize machine learning to everybody. Now, machine learning has many qualities that make it well suited for helping with game development problems. In fact, we believe that some of the hardest problems can only be solved through machine learning. So we've been using games to develop machine learning models for years. And so we have a fair bit of experience in this space. I'm going to see if I can get rid of the bar at the bottom. I'm going to go. There we go. All right, so we have two animated GIFs here. Basically what we did is we threw a machine learning program at Breakout. And on the left here is you see how it played initially. That is to say, not very well. We gave it the sort of goal of increasing its score, and you can see at the start it's not even reflecting the ball back at all. Within a few hours, however, it had completely mastered the game. It had worked out that if it creates a gap on the side, it's able to get the ball to go bounce to the top wall and then bounce between the wall and break the wall from behind without having to use as much effort of moving it around. And it did it entirely itself. So these are some of the types of machine learning challenges that just work better in the cloud. You may have heard of AlphaGo. We have have any of you heard of AlphaGo, by the way? Yes, excellent. About half. So Go is an old game. It's a very complex game. It's the number of sort of moves that are possible with Go are far beyond what's possible with chess. And up until recently, Go seemed like one of those games that was really hard to penetrate with computing, because even though we have all this great computing capacity today, Go has such a deep tree of possible moves that was really hard to brute force. AlphaGo beat a number of world champions at Go and made a name for itself. And the way that it actually did that is that we had AlphaGo, we gave it the set of rules of Go, and we had it play itself. It played against itself 30 million times to train itself. And it's able to do that rapidly because we can do it in parallel in the cloud and get through many more iterations of those games. So across Google, machine learning is finding more and more applications in our products and projects. For any of you that use Gmail, our spam detection is built on machine learning models. And whenever it gets it wrong, if you mark something new as spam that it should have categorized, it learns from that and improves its model to get better next time. If you use Google Photos and you go and search your photos library for that picture of, if you just type in the word cars, it'll automatically bring up photos of cars for you. Not because someone went and tagged it, but because machine learning is able to identify those objects. And we do the same thing with locations and so on. So you might say, well, what's in it for game developers? So we think we're only scratching the surface with some of these ideas, but we can see ML being used to build QA bots for helping you test your levels, for helping you validate updates to game mechanics. We can see you potentially, if you've got global games, you could do real-time chat translations so that you can be able to easily communicate between people that are across language boundaries. Matchmaking is obviously a good space as well, as are things like fraud and cheat detection, which developers could benefit from. So machine learning is a great buzzword, but it turns out very few people are really good at solving hard problems with it. And we're working very hard to make sure that machine learning is accessible to more and more people. So we've put together a new website, ai.google/education. And this new website is packed with tons of resources. And what you can do is you can tell the site what kind of background and skill level you have, and it will filter that content for you. You can watch videos, take a course, and get hands-on with machine learning as well. It's all entirely free, by the way. And then when you're ready to dig in, you can get access to some code as well. So Unity and Google Cloud together are going to accelerate the entire game development lifecycle. We want you to be able to innovate with unique cloud infrastructure, build faster, fail fast and learn, and finally launch globally at scale. So I'm really excited to see what we have to share with you in the coming months. So stay tuned for our big announcements. So you might say, well, what's some tangible stuff that is coming to you from Unity's standpoint? So we're not able to give you specific dates, but I do want to show you kind of a peek behind the curtain there. Once we started sort of on this initiative, prior to that and even after it, we've spoken to many game developers, and based on those conversations, we've decided to focus on real-time multiplayer technology first. Essentially that level 3 that we talked about earlier on. So I already covered some of the benefits of dedicated game server topology, and Unity has decided to invest in a breadth of technologies to make this option available for developers. So we want to give you proven orchestration tech in games like Titanfall, seamlessly scaling up and down servers as needed by your game. Multiplayer and GCP together can scale your game to serve millions of players in minutes. And we're going to do it at enterprise scale, so you can optimize costs across bare metal and cloud. It'll come with premium support 24/7, and actively we're working to make this tech more accessible to all game developers. So now that we have the ability to host game servers, what are we going to actually run there? Does the physics need to match your game? How will you determine if a projectile hits the target? So we know that some developers are already using Unity's headless runtime for their servers, and Unity's also heard that headless runtime might need to slim down a little bit, so they're working on that right now on optimizations to CPU, memory, and increasing uptime. And longer term, there'll be packages that enable more modular server architectures, server runtimes. So how do you get your server runtime to multiplayer servers, whether it's using continuous integration and automated builds with Cloud Build, or if you upload directly, you'll have the ability to push a Linux build to your choice of multiplayer server. Unity is also working on command line tools that enable you to leverage this functionality automatically from the editor. This simple workflow will still be powered by the enterprise-grade hosting technology multiplayer is known for, with a much more accessible pathway and faster iteration with your server builds. And finally, with your servers running, how are you going to monitor their performance or view logs when there's an issue? The developer dashboard will provide you all those capabilities. Once player game clients are connected to the server, how are they going to pass information to one another? There's a new networking runtime that's being built from the bottom up, starting with a transport that will be minimal and lightweight to achieve the fastest transfer speeds. And to vet the implementation, Unis are actually going to build real game samples, starting with a classic FPS. And the model that they're going to use is an FPS that has a dedicated server. So they're going to provide client-side prediction and lag compensation and provide you the source code of both the server component as well as the client. So the next question developers ask is, once I've got all this infrastructure, how do I group people together? How will multiplayer know to pair people up? And that's with the open source matchmaker project called OpenMatch that Google has started to build and is working with Unity to provide a hosted version of it. And in room 210 at 3 p.m., I'll be doing a deep dive into OpenMatch. So please come along if that's of interest to you. So there's a lot more happening from there. We're still figuring out what's most needed by developers. So continue to share feedback because your feedback is really helping us drive this product. So to summarize, Unity and Google are each industry veterans with a wealth of expertise. Google is bringing massive scale cloud services. Unity is bringing fantastic game developer workflows. So we see this as a melding of minds here. So I hope you're as excited as I am. Thank you very much for coming today. I'll open it up to questions.